This fall of 2020 marks the 50th semester that I'll be teaching class or a class at the University of Kansas. Because of COVID, this semester will be far different, though, than any of the 49 that preceded it. I've taught ECS 622 about 20 times, and because of that, my syllabus has converged to steady state. I don't have to make very many changes from year to year, but again, because of COVID, I've had to make extensive changes in how the course is going to be conducted during the semester. So this syllabus is going to describe partly the components of the course, what we'll be studying from an academic sense and why, how you'll be evaluated, but it'll also spend a lot of time talking about the logistics of this course. How are we going to send content and educational value to you? How am I going to evaluate you and send a grade given, again, the constraints of COVID-19? So please pay attention. First of all, let's talk about a little bit about the class. I'm going to turn on my red laser pointer here and point to the screen so you can tell where I'm referring as I speak. So what is ECS 622? The title says it is microwave and radio transmission systems. Essentially, this is a course on radio engineering. If you go through and you look at all the little gizmos that you're familiar with, all of these gizmos that we have now are wireless. They're connected in a way where there's no direct cables for the most part. And so there's sort of a miracle that happens. We have data one place and it shows up at a different position, again, without any obvious physical interconnection between the two. If we look at the block diagrams for these things, they're very complicated blocks of processing of data and such that happens. And then we get down to one edge, there's one little block that says something like transmitter. On the other side, there'll be another complicated set of blocks that describe all the interconnections of processing that happens. But at the beginning of those blocks, there's one little box that says receiver. So the information gets processed and handed to a transmitter, and then magically a receiver then reproduces the signal at some other place. Well, what goes on in those two boxes? What is a transmitter and receiver, and what happens between them? That is really the point of this course, is to understand those things. Not how do we process the data, but once we have that data ready, how do we transfer it from one point to the other? What are the electrical engineering systems that require for this to happen? And what we'll find is the components in those systems are far different than the blocks, the components in the other blocks that describe our wireless devices. We're going to have new components and new devices that you have not at this point studied probably in your electrical engineering curriculum. And so we'll talk about those components and how to put them together to build microwave systems. I suppose I should start by introducing myself, rather. My name is Professor Jim Stiles, and as I alluded to earlier, I've been here a long time at the University of Kansas. My office is in Eaton Hall on the third floor, kind of the electrical engineering wing of faculty there. To what extent that makes a difference this semester, I'm not sure. I don't know how much I'll be there, and probably a few of you will be in Eaton Hall either. So, but that's there for information. The best way probably to contact me, certainly this semester, is via email. My email address. Now, we'll be having office hours, but we're going to try to do them via Zoom, unless we have some problem with a specific student where we need to get together physically, and then we'll try to do it at Eaton Hall perhaps. Otherwise, we'll do office hours via Zoom. I imagine they're going to be on Tuesdays and Thursdays. I am not sure of the time yet. I want to make sure that it works well with the class, so I'll propose a time, and we'll see how that works out. It might change. I want to make sure that we cover as many students as possible, and everyone gets a chance to attend office hours if they need to. Something about myself. I was raised in the Kansas City area on the Missouri side. After high school, I went on to the University of Missouri. You may have heard of it. And there I studied electrical engineering. After I graduated with a bachelor's degree, BSCE, I went down to Dallas and I began work as a design engineer for Texas Instruments. Now, most of you think that Texas Instruments, makes calculators, but certainly back in the day, that they had two major products. One was semiconductors, which is still their major product to this date. But the other was a group that did systems like radar and sonar and infrared imaging and sensors. That group has been sold off since my time there, but it was a very large group, and I worked on designing wideband microwave radar receivers. And I worked there for 8 years as a design engineer with a bachelor's degree. And because of that, I have a very good affinity for what kind of job you probably will end up taking. Most students aren't going to be going through and getting a PhD and then becoming a professor. Instead, they're going to get a job as a professional engineer in a large, perhaps a large electronic firm like Texas Instruments, and they'll be doing design work. And so that time there, I was there 8 years, has really helped me as a professor, I think, in terms of teaching. I really have a better understanding of what will be expected of my students when they get out and get a job, very similar to the one I had in 8 years. With respect to this class, this 8 years is the most important of any of the classes that I teach, in that a very large amount of the material that we'll be discussing in this class is material that I learned while I was there at Texas Instruments. It's not material that I taught, or I learned rather, in any specific class, in undergrad or graduate. It really is sort of meat and potatoes electrical engineering, pragmatic knowledge that's needed to design radio systems, transmitters, and receivers. Because of that, I don't know that there's a course like this anywhere in the world. Probably there is, but I don't know of any. Some, I think, unique with respect to the electrical engineering curriculum. The things that we will cover here. Now, having said that, it doesn't mean that it's a niche class by any means. These are very important concepts in most electrical engineering systems, more so now than ever because of all the wireless systems that we have. Industry, when they come and talk to us, are oftentimes frustrated by the fact they can't find electrical engineers that know about these topics, that they have this great need in industry of having engineers that with this expertise, yet very few of them have been able to acquire it. And again, largely it's because very few courses like this are being taught. So hopefully this will be a course that will be valuable to you throughout your career. After 8 years at Texas Instruments, I decided that I wanted to go back to grad school and learn more. So I went to the University of Michigan and I earned a PhD. And after getting my PhD, I thought I'd go back to TI, but this job opened up here at the University of Kansas, and I applied for it. And to my amazement, I was offered the job, and so I've been here ever since. So now let's talk about how we're going to deal with the COVID restriction on our classroom, and that's the big problem that we have. Right now we have 19 students. As of the day before classes start, we have 19 students enrolled in the class. The problem is in 3150 Learned, there are only safely space for 13 students, actually 14 people. Of course, I will be in there, so there'll be 13 students. And we cannot exceed this capacity at any time, so that's a strict rule, and bad things will happen to all of us if we have more students in there or people in there than the 14 limit. And so we are going to strictly adhere to that. So how are we going to do this if we have 19 students enrolled in the class, yet we only have 13 seats? If you look, when you enrolled, you probably found that there are two learned sessions for ECS 622. One is a in-class at 3150 Learned, and the other is a quote online class. Now, there really aren't two sections. We're all just one happy class, 19 of us together there. And the course will have to be done this semester, though, where you can take in the content either by coming to class or by viewing the content in a distance learning format, recorded or lecture or live via Zoom. It's up to you. We'll talk about that in the next slide, how that's going to be done. And it's up to you in terms of how you want to do it. We'll talk about in the next slide. The only criteria is we have to make sure that we don't exceed 13 students at a time in 3150. So depending on how many of you want to come to lecture, and that's something we have yet to determine, if there are more than 13 that want to come physically to learn at Hall and attend class, we may have to go through and go to more of a hybrid course schedule where KU talks about cohorts. You divide the class, for example, into 3 groups, A, B, and C, and Group A comes to class on Monday and Wednesday, and B on Monday and Friday, and C on Wednesday and Friday, for example. And then, of course, the day that you are not in class, you would get the material via some distance learning method. So what are we going to be doing? What's the schedule for that? Again, I don't know. The first question that I need to find out from everyone is, what is their preference? How many students either cannot or don't feel comfortable coming to learn it? How many students want to come to in-person class as much as possible? Once we have that information, we can go through and figure out how to do a cohort schedule, which will ensure rather that we never exceed this limit of 13. So details will be announced once the final enrollments are completed, and again, once I find out from you all what are your preferences with respect to class attendance. The academic content of ECS 622 can be acquired in 5 ways this semester, and it's up to you as to which of these 5, all of these 5, one of these 5. Again, it's completely up to you which one or ones that you want to take advantage of to learn the material. So let's talk about those 5. The first is participate in the live lectures. Come to ECS 3150 and listen as I give the lecture. So I'll be here every Monday, Wednesday, Friday, 11 to 11:45 to give the lecture. Of course, I'll have to be wearing a mask during that time. We'll talk about that later. And of course, that's subject to restrictions. I said you can do this, but we have to make sure that there aren't more than 13 at any given time. The second way is connect to Zoom, via Zoom, to watch the lecture live. So in addition to doing the lecture live, I will have a Zoom connection, and from the Zoom connection then you can tune in, as it were, and listen to the lecture live and be able to ask questions. I think we'll have to figure this out as we go on. I haven't ever done this before, so I'm sure there's some technical glitches that we'll have to overcome there, but ideally you'll be able to ask questions during the lecture, even if you are not physically present. Now, one nice thing about Zoom is you can record the lecture, so I'll record the lecture, and that way you can use this to affect in one of 2 ways. One is you can say, well, I won't tune in for the live lecture, but I'll watch it later. The other way, which I think is more effective, is to either go to the lecture or watch the lecture live and then go back and review what happened by watching the recording. It's very difficult to sit there and listen to anyone drone on for 50 minutes, and certainly that's true for me to listen to anybody for 50 minutes with perfect concentration and pick up everything that's said, or even most of the things that were said. It takes multiple times, multiple exposures to the same presentation before all the concepts are really absorbed. So I think going back and going through the lecture more than once is very beneficial. Now, in addition to that, I am putting together a set of presentations which I'll put on YouTube, and I use this package called Camtasia that allows me to make these videos. You're looking at one right now. If you're listening to this, you're looking at one that's made there. And of course, the nice thing about this is I don't have any mask. It has a better production value. Probably it has more information because I'm not constrained to the 50-minute time window, or at least the 45-minute time window for this semester that we have. And I'll put these on YouTube. This is what I did last in the spring when we shut down for COVID. This is how I delivered my lectures, was doing this YouTube channel with recorded in this way. And then the fifth way of getting the material is that all of the presentation material, all the notes, are posted rather on the EECS 622 Blackboard site. So they're all there, and you can go through and simply go through and read them and look at them and think about them. Now, which one is the best? I would say they're all good, and in a perfect world, I would want you to do all of them. Either listen to the lecture live or on Zoom, go back and rewatch the lecture again, go through all the YouTube video presentations of the material, and read the material. Maybe there's an order that makes sense for you to go through and maybe read the material before you look at the YouTube presentation. As you read through the material, there'll be things that you understand and get. And feel like are pretty straightforward. There'll be other things that you're not quite getting what's going on or what's happening there. And so as you look through the presentation, either on YouTube or on the recorded Zoom lecture, you can go to those parts and spend more time rewinding and going through them until you make sure the material is clear to you. All right, one thing that we need to make clear, and hopefully this is obvious, this isn't just my rule, it is a rule all across KU, and that is if you want to come to class in Learned Hall 3150 and attend, that you must wear a mask. And that's true not only in the classroom, but all times when you're inside Learned Hall, you must be wearing a mask. And by wearing a mask, we mean, excuse me, properly wear a mask over your nose and your mouth. All right, I'm covering my mouth, but not my nose. It doesn't work. It turns out that the COVID, the viral loading is mainly in your nose. So your nose is really the place that's most dangerous with respect to everyone else in the room. So you need to make sure that you keep your nose covered, but your mouth as well. All right. So if you're not in class with a mask or properly wearing the mask, we have a problem. I'm going to ask you to put on a mask or wear it properly. If you refuse, then I'll simply have to stop class and dismiss class for everyone. That's so one way or the other. You're not going to be listening to my lecture without a mask. If this is a problem and you refuse to, then simply you will not pass the class. I'll give you a failing grade. It will ask you either to disenroll if you refuse to wear a mask, and if you don't, then you will get a F for the grade, which that is KU policy now, that if you refuse to wear a mask and refuse to disenroll, then you will not get credit for attending that class. Again, the class can't occur if you refuse to wear a mask, so make sure that you do that. I don't anticipate this being a problem. The nice thing about this, if you don't want to wear a mask, if you have an objection to it, you can certainly partake in the class fully without ever walking into 3150 or Learned Hall. So it's not something where you can still go through and do the class without wearing a mask. So in a second, I'll talk about the requirements for the class, but needless to say, we'll be having exams. In 622, we're going to have two midterm, quote-unquote midterm exams, two exams during the semester, and one comprehensive final. Now, of all the things of COVID that has done to us, the one that's most problematic, I think, is how to do evaluation, and specifically how do we do exams. Our window for a class is 11 to 11:45, and I could try to go through and give an exam. Of course, we have everybody there at the same time, so it's going to have to be sort of a distance, sort of take-home version. I could send out the exam at exactly 11 o'clock and then tell you all that you have to complete it and scan it back in and send it to me by 11:45. But frankly, the process of you downloading the exam, printing it out, and then scanning the result back in and uploading it back to me will take 45 minutes before you even do any work on the exam. So I have to give you more time than 45 minutes, certainly, to be able to do that exam. That becomes problematic because some of you will have another course right after this one. And so where do I put the time window for that? Ultimately, I need to expand the time window such that any person can reasonably get it done in the time window, given the other constraints they have, other classes they may have. And so I'll have a start time and an end time, and it will be multiple hours probably, and you have then time to download and do the exam and get it scanned back in and uploaded during that time. Now, the problem of multiple hours is one of security. I will make you sign a pledge that you are, in fact, this is your submission is due to your knowledge and your knowledge alone. But of course, that's a problem in these days with COVID and these distance and any kind of take-home exam. There, hopefully, that won't be an issue in this class, but that's certainly a fear. The bigger fear, actually, that I have, and the one that showed up, I think, in the spring, is that students say, "Oh, well, gosh, I have lots of hours to this exam. I'll just wait until the exam comes in before I actually do my studying for it. Why am I going to go through and figure all this material if I'm not sure what's going to be on the exam? I'll just wait and find out, and then I will stick my nose in the material and figure it out during the time I have available for the exam." Well, you're not going to have enough time. Students think they are, but they don't, and you can see it on the exam. The students that simply said, "Well, I'll just wait and see what the exam asks, and then I'll try to scan through all my material and find the equation, the right equation, or the right answer." My exams are such that you're not going to find the right equation on one page. The problems are such that you take bits and pieces of different information in different places and different understanding and put them together. There is no one right equation. There's simply an understanding of the material. Make sure that you study energetically for the exam. The key thing in the material is, for this class, is not to understand the material to the extent that you can pass the exams in the final. The key thing is that you understand the material so you can go on and become a successful electrical engineer. You can take this material and be productive to your company, and your company will reward you and favor you greatly if you can. One thing about this semester that I decided to do reluctantly and somewhat sorrowfully was to go through and get rid of the receiver design project. It's been a mainstay of this course ever since I started teaching it 20 years ago. The last thing you do in the semester is go through and design a superhet receiver on paper. Then you analyze that design and submit a report that talks about the different specifications that result from your analysis. And you want to design it in a way that those specifications meet some minimum standards and constraints that are defined in a large document that puts those design constraints to the student for the project. Now, this project is a group project. And it happens again at the end of the semester, which I don't like, but it takes all semester to learn the material to be able to do design. You can't do a receiver design until you've gone through the material of the course. So it happens at the end. So both those things, happening at the end of the semester and making it a group design, is problematic this semester. The last day of class will be just before Thanksgiving, and so we don't have as much class time as what we would have in the past. And of course, trying to do group projects, I think in the epidemic where some people are at Lawrence, they're back at their home, for example, it just becomes too problematic. So we're not going to have the exam. It's maybe good or bad news to you, depending on your viewpoint. One thing is that students often, there's two comments that students make about the project. One is they talk about how much they learned, about how beneficial it was to them. Oftentimes students are very sort of excited and proud that they have a design that they made for a microwave receiver. Oftentimes the courses that you take are theoretical in nature, and you did a lot of homework problems and test problems, but from an electrical engineering standpoint, it may seem a little bit unclear as to how this is important. But in this case, you have a hardware design. You have design that you've done and that could be built and would be effective in the requirements that are delineated in the project statement. So a lot of students, again, really appreciate the project. On the other hand, it is a lot of work, and it's a lot of work at the end of the semester, and so it causes stress for students, and I don't like that, and I wish I could figure out some way of changing it. I've thought about getting rid of the project because of this stress, but again, I get so much positive feedback, and students seem to enjoy it from the standpoint of their academics that I've left it in. Up until this year. So this year there won't be any project. You may have heard about the receiver design project for 622, but it is not going to occur in fall of 2020. So let's look at the weighting of the different deliverables for this class. Again, we'll have 2 exams. Each one will be 25% of the grade. We'll have a final exam, which will be 35%. This is a comprehensive exam. Homework would be worth about 10%, and well, exactly with 10%. And then also we'll have some quizzes, and these are online quizzes, multiple choice, true, false, and the like, that you go through that are graded by the computer, and they're worth 5%. And really, these are sort of material knowledge, I guess, basic knowledge that I want to make sure that you have extracted from the material. So the quizzes will be different than the homework. The homework will be more of an analysis and hardware design and such. Toward the end of the class, typically I sort of taper the homework off because people are working on their project, but this semester, since there isn't a project, I'll probably move a few of the tasks that I can from the project to the homeworks, and so you get some activity that is relevant to the receiver design. One thing to point out is the majority of the points will be accrued toward the end of the semester. Again, if you look at the exam 2 and the final exam, that's 60%, and that these will happen probably, exam 2 will probably happen in November, and final exam will of course happen in December. Students are generally interested in how I assign grades, what they need to do to get an A in the class, for example. And as a first approximation, I use this sort of the standard metric. If you get a 90% total in aggregate in the course or better, then you will receive an A. If you get an 80% aggregate or better, you will receive a B. However, I will go through and lower those lines almost certainly below 90 and 80 and so forth. What I do when I assign grades for a course is at the end of the semester I look, tally all the aggregate grades, and I look at them and I try to find a gap between students, and that's usually the way it works. I kind of cluster. I'll go through and go to 90 and then keep dropping, and there might be somebody at an 89.3 and an 88.9 or something like that. I put them I assign them an A. And what I look for is finally there's a gap that's statistically significant between students, and then I draw the line. Where is the line then? Is it at the highest student or lowest student? I don't know. There's just somewhere between the two students that I divide them up. What I want to do is make sure that if I have students that get an A and a students get a B, that there's some statistically significant difference between the two. That there's not simply a matter of a few points that separate them, because if there is just a few points that separate them, then they deserve the same grade. 622, like most electrical engineering, the grading is somewhat subjective. This is not spelling words or state capitals where the answer is either clearly yes or clearly no. There's some subjectivity in the grading and partial credit, and so because of that there's some uncertainty, some error bars associated with every grade, and I take that into consideration when I assign the letter grade. I make sure again that there's some gap between students. With 19 students, it's not really even an issue. There almost always happens where it becomes pretty clear what cluster of students are the A's and which cluster are the B's and so forth. But you get an 87 in this class, you may still get an A, depending on how the clusters all kind of work out. Now, the reason I tell you all this is because you don't need to worry about a few points making a difference in your grade. Every student worries that, that one homework point, will be the difference between falling on the A line or the B line. But 1 point is not statistically significant enough to alter your grade. It's not going to be enough to move you from one cluster of students into the next cluster of students. So don't worry about the few homework points or exam points and the grading and the partial credit. In the end, I understand that it's a kind of an estimate, and I take that into account when I assign the letter grade. The schedule for the course, roughly the course is divided into 3 different sections. The first part of the course I call Microwave School, and that's going through some of the fundamentals that are required to talk about high-frequency components. The thing that separates microwave and RF design engineering from other parts of electrical engineering is the fact that we assume our signals are A, time harmonic, in other words, they're sinusoids, and B, that they're sinusoids at very, very high frequencies. What separates a high frequency from a low frequency in electrical engineering? Well, it's pretty simple. The question is, to what extent is a wire a wire? At low frequencies, a wire is simply a wire. The voltage either is the same, the current coming into one end of the wire is the same as the current coming out. We can apply KVL and KCL, and it becomes a very simple connector from one device to the other. But at high frequencies, that turns out not to be the case. It appears that KVL and KCL are not relevant because the current coming into the wire may be different than the current coming out of the wire at the other end, and the voltage at either end may be the same. The reason for this, as we'll talk about later, is because of the inductance and capacitance of the wire. The wire cannot be viewed as a simple connector as we did in low-frequency circuits. It itself becomes a lumped element device, a two-port device that is reactive and therefore changes with frequency. And that's really the major theme that we have in the first part of the course. That makes things complicated. We'll find that there's a solution, more or less, that will at least minimize the complexity that is associated with transmission lines in microwave engineering. Second part of the course, we're going to start talking about the components that we use to build transmitters and receivers. This part, I talk about things that are associated with frequency, generating sinusoidal signals, filtering sinusoidal signals, moving the frequencies of signals up or down, and they're all considered now in this section. At the end, we start talking about receiver design, superhet. We know enough at this point to start talking about superhet design. The next part of the course, then I talk about controlling power. And the other part we need to do in terms of moving the frequency of a signal up or down and filtering signals based on frequencies is we need to change their energy, their power. We need to, generally speaking, increase the energy of the signal that we're interested in receiving. And of course, this allows us to talk about things like amplifiers and attenuators and couplers and such. The other thing that we talk about, one of the main topics of microwave engineering and receiver design is the idea of noise. How big do we need to make the signal? Well, we need it big enough that it is large in comparison to the noise. This is actually much more difficult than you might expect because the devices themselves, like amplifiers, add noise to the system. So understanding how noise works in our receiver is every bit as important as understanding how the signal power is affected as we move through a receiver. In the end, what we care about at the end of the receiver where the signal exits is what is its signal-to-noise ratio. How big is it compared to the noise? So these are the three sections. Notice I have an exam after section 1 and in section 2. These are sort of notional ideas of where the exams will occur. Oftentimes we have to take into account other things like scheduling in there. In this semester, this might be a little bit easier because we don't have a fall break. We don't have a Thanksgiving break, which usually causes problems with my exam scheduling. So we'll just kind of see how it goes. Of course, this last part, controlling power, then would be on the comprehensive final at the end of the semester, as would material from the first two courses. As I said earlier, this class is kind of meat and potatoes electrical engineering. It's not a lot of theoretical stuff. There's some in the first section we talk about microwave school, but for the most part it's straightforward in terms of the material and very practical and pragmatic with respect to the uses in electrical engineering. This causes some problems sometimes for students because if you look at the math, oftentimes, and certainly in receivers, it's very simple. It's addition and subtraction and multiplication and division, and that's about it. Sometimes students decide, oh, well, the math is so simple, I don't really need to figure this out. I'll just go through and search through my notes until I find, quote unquote, the right equation. But what to find there is you can't find the right equation. This is a situation where if we look at a receiver, for example, we'll find it is a sequence of pretty simple operations where we change the frequency and or power of the signals we're interested in, ultimately to a place at the end of the receiver where we have the right power and signal frequency that we desire, while simultaneously taking all the other signals that come into our receiver from other radio stations and moving them to a different power, lower power, and a different frequency far away from the desired frequency at the end. So we have this complexity there of trying to move something that we want to a certain place while simultaneously moving everything else to a place where they do no harm at the end of our receiver. Simply changing the frequency up or down, changing the power up or down. The math is pretty straightforward. Yet there's a complex sequence of these simple transformations. To understand what's going on and why, you have to understand these transformations. What are we trying to accomplish here? Why do we do each step? Why does it make much this sense? The goal of this is to make all this make sense to you. Not to simply write down equations, put them on your cheat sheet, and look them up and plug in numbers. That's not going to work in this class, largely speaking, because of this receiver. You have to understand what's going on. The problems in this class, I always say, are kind of like cookie problems. If I went through and I said, okay, let's say you're asked to bring 100 cookies to a party, and you look in your cookie jar and you only have 67 cookies in there. How many cookies do you need to bake? Well, you'd be able to figure that out. You didn't need to go and look up in a book, look for Kirchhoff's law of cookie baking and figure out what the right answer is. Oh, X is the number of cookies I have. Y is the number of cookies in my jar. Z, therefore, is the number of cookies that I need to bake. Put in the numbers and wait for the number to pop out. No, you know, based on your intuition and your understanding of math, how to solve that problem without finding a certain equation to look up. And that's the kind of, oftentimes the kind of problems we have in this class. If we replace cookies with milliwatts or megahertz, you have pretty much the same thing. We need to know how much signal to add or signal frequency to subtract, how much energy to add or signal energy to subtract to come about with the desired value there. Be able to do that, you need to understand the problem. You need to be able to formulate the problem and understand how much to add or subtract there. You're not going to find an equation for that. So you need to go through carefully and really understand the material here and not just think that you can look up the right equation and get the right answer. You have to make all of this make sense to you. Now, this is true really of any electrical engineering course. In the end, you should not really care about whether you get the correct answer or not. What you should care about is whether you understand why the answer is correct. Nobody's going to hire you and pay you a lot of money to put numbers you don't understand into equations you don't understand and get other numbers you don't understand, even if those, in fact, are the right numbers. They have computers that can do that. Instead, you have to understand why those answers are correct. So then you can use that mathematics to solve problems, to answer questions for which there is no known question. You have to come up with the question and then the solution. That's the nature of engineering. You really have to understand what's going on. I talked about the fact that I had experience at TI as a professional engineer, as a working design engineer. And, I worked there for 8 years and I saw a lot of engineers that were extremely successful and had tremendous careers. I worked on interesting things and were well rewarded for their productivity. I saw other engineers that simply washed out, that could not do the work and had to go find effectively another career somewhere else. And the difference between those two is to what extent that they really understand the things they learned in engineering school. Did they make it make sense? Did they have some vague notion? And gee, I knew that once, but that course was that was a year and a half ago. I don't remember anything about it now. Or did they acquire information and understanding as they went along, so they could bring it to the workplace and add value to the company that had hired them? So what I want you to do, what I try to do as a professor, is try to emphasize and really demand that this stuff makes sense to you. How do we do that? Well, it's a process of studying, read and think and read. In this course, we have about 1,400 pages of presentation material, like you've seen here. Now, that seems kind of overwhelming, but again, each page isn't doesn't have very much on it. I get through all 1,400 pages in a semester, more or less, so you can go through and certainly have plenty of time to go through all 1,400 pages, provided that you start at the first day and go through and do a few pages every day throughout the semester. Make sure you understand what's going on before you come to the next lecture or view the next lecture. If you do that, you'll find that the pieces fall into place pretty easily, and it's not a particularly difficult or complex problem to solve with respect to the assignments in the course. However, if you just ignore everything and wait till right before the exam, or wait till the exam to try to put the pieces together, there's no hope. So make sure that you go through, read the material, just don't look over them. I always ask students, did you read the material? Oh, yeah, I looked over them. I'm like, okay, but did you read the material? Oh, sure, yeah, I looked at them. But did you read them? They keep saying yes, but in the end, they never actually say, I read them. And the reason, because they didn't read them. It is going through, reading is starting at the first page with the first sentence of the first paragraph, and then moving on to the second sentence and the second sentence and the second paragraph and the second page and so forth, until you go through all the course in a way such that it makes sense to you. And again, I've given you enough material here between the videos and the written materials and the lectures that you should be able to put the pieces together and figure out the concepts of this course. I tell students that studying is a little bit like painting the walls of a house, for example. You have to put on more than one coat. You go through and you paint over it, and you go back and you paint over again, and then you go back and you paint it even a third time. And that really is how we go through and acquire knowledge. Nobody can go through with the complexity of electrical engineering and simply read something first and go, oh yeah, that makes perfect sense. I got it all. I don't need to spend any more time on it. You go through it the first time and you're like, okay, some of that made sense, but I'm not sure about the rest of it. And there were parts I just had no idea what was going on. Go back and go through it again. We have a situation, electrical engineering, let's say there are 100 things you need to know. Well, because time is in one dimension, we have to cover the first one first and the 100th one last. But the first thing may be uncertain to you because the other 99 really had something to say about the first one. So you go through and you sort of defeat the one-dimensionality of time by going through all 100 elements, and when you get to 100, go back to the first one. Now you're rereading the first part of the course with the knowledge of the remaining part there. And now the first part will make more sense, and the second part will make more sense. And when you get back to the 100th part, go through again the third time and just cycle through again. And if you cycle through, you'll find that at some point it'll all start to become very clear and will make sense to you. So go through and read and think and read, and repeat the process as necessary. Now, there are going to be some places in there where you go through and you cycle through 2 or 3 times and it still isn't making any sense. There's one part, maybe just one sentence, maybe just one equation that is like, this seems to be contradictory. This doesn't make sense. I just don't see how this could possibly be true. What you've done there is very important. You become knowledgeable of your ignorance, I like to say. You've figured out what it is that you don't understand. You've figured out what it is that is causing you problems there. Now, you could sit there and hammer on it for a long time to try to figure out, or at that point, that's where office hours come in handy. Go to the professor and say, listen, I went through and I read all this and I understand this and this makes sense, but right here, this part, this thing, this is where I'm confused because, and this is why, it's because it seems contradictory or it seems to be incomplete in terms of its presentation, and the professor will be able to help you out. So, and that's office hours work much better when you become knowledgeable of your ignorance. Sometimes students can't do the problem, but they don't really have any idea why they can't do the problem. They don't know what part of the material they understand and then what part of the material they don't understand because they haven't really engaged in the material long enough to be able to come to that conclusion. They have not become knowledgeable of their ignorance, and so try to do that as you go through and study this course. And then again, once you find the problem spots, come to office hours, in this case virtually, and we'll get you fixed. This course is going to be organized into a Blackboard site, and if you're viewing this, probably you've found the Blackboard site by now. This is where everything will be kept with respect to the important information of 622. All the course documents, the syllabus, for example, all the course notes and presentations, 1,400 pages of them, will be listed there, so you can look at them or print them out if you want, download them. Homework assignments will be listed there. All the homework solutions will be listed there. Any course announcements that I have about homework being assigned assigned or upcoming exam will be listed there, and the email will be sent out automatically when I do that, and then there'll be a grade book, of course, you can look at with your grades. So everything will come through that. And again, most of the announcements I have in class I will put on the Blackboard site. I won't mention during lecture. I'll just assign homework after lecture and then send out an announcement, and you'll be able to find them in your Blackboard site. So one thing I'll point out, solutions are there for all the homework. I spent a lot of time writing down the solutions in a way that will be helpful to you if you did not understand how to do the problem. My assumption is if you're looking at the solution, it's because you didn't do it correctly. And so rather than simply give you the answer, which again I find to be insufficient, we don't want to simply get the right answer. We understand why the answer is right. So I go through and try to put a detail in the solution so that you can understand why the answer is correct. Why did we come to the conclusion that we did? They're really more of examples that we have, homework examples for each problem. So I would emphasize trying to go through and look at the solutions. Even if you got the right answer, go through and look at the solutions. You may find that you learned something about how to do it, maybe a better way or a quicker way, or gain some insight as to what was going on in that problem. One last thing is that all the notes that we have in this class really are the textbook. Students ask me, what's the textbook for this class? Really, there isn't any. Again, there really isn't a course, to my knowledge, like this anywhere, and so there are no real textbooks for a course like this. If you look at the print version of the syllabus, I list some suggested books. They're about all there is out there. Most of them are no longer in print, so I don't know if you can find them. They'll probably be in the library if you can get in the library this semester. I don't know that they're necessary. Like I said, I think my material that I present is completely sufficient for learning the concepts of this course. Yeah, so like I said, they're there if you want to look at them. Otherwise, if you have any questions about the course and the requirements and such, send me an email or show up for virtually on office hours.